Welcome to CHEM2005. Today what we will do is how to synthesize pyridines. Okay? This is a pyridine, as I told you the other day. It's a 6-member ring, aromatic, electron poor, etc. Okay, and now I will explain how we can synthesize it. Okay? I will explain one method. There are two basic methods. Okay? One is through 1,5-carbonyl compound, very similar to the synthesis of pyrrole that we saw with 1,4-carbonyl compounds, and the other is called a Hansch ester synthesis. Okay, a Hansch synthesis of pyridines. We will start with the first. Okay, this is a pyridine. We have two substituents in the position 1 and 6. Okay? And the first retrosynthesis is basically what we do is we reduce this pyridine to a dihydropyridine. Okay? What we do is we remove one of the double bonds and we generate this compound that is not aromatic. But now, this compound, if you check here, this is not any more than an enamine. It means that this can come from this ketone plus this amine, but if you take a look, this is another enamine. That means that this could come from this 5 dicarbonyl compound plus ammonia. And how is coming this 1,5-dicarbonyl compound? Remember that the 1,5-dicarbonyl compound normally comes from the addition of an enolate to a alpha-beta unsaturated ketone in this case. Okay? That means this is the first synthesis of the pyridines. How is working? Well, we can do an example. I will do a very easy example. We will try to synthesize this pyridine. Okay? This diphenyl pyridine. Okay. Then, if I do the retrosynthesis, I have to start from this compound. I will start from the carbonyl compound. I will synthesize the alpha-beta unsaturated carbonyl compound, and then I will add the nucleophile. In order to do the alpha-beta unsaturated compound, what I do is a manage, remember. I add carbaldehyde, dimethylamine, first step in acid. Second step, methyl iodide in excess. Third step, base heating. And what I get is, I hope that you remember the mechanisms, okay? We get the terminal double bond. When I have this compound, basically what I add is the other part with LDA. I form the enolate here, and then attacks here. Protonate everything at the end, and what I get is the 1,5-dicarbonyl compound. Then what I do, here I have two options. I will start with the first option, that is the one that I explained, that I did the retrosynthesis. Basically, I add ammonia in acid media. What is happening? We protonate one of the ketones. Normally it's the less steric hindred ketone that we will protonate first, but at this level you can do it with any of those ketones because the final product will not change. Okay, what we get is, I don't do the mechanisms because I hope that you already know this mechanism, the formation of an imine. Okay, next, tautomerization, imine and animine. Okay, I protonate the second ketone, and the pair of electrons of the nitrogen will do the imine again. What I get is this tautomerization to the enamine, and I will get the dihydropyridine. Okay? Tautomerization. Okay, I get the dihydropyridine, and now in order to synthesize the pyridine, what I need to do is to oxidize this. How? Normally I can use, for example, air, okay, boiling, this also is working, or using can. Okay, I will write better. To transform a dihydropyridine to the pyridine, I can use air. Air is an oxidant, basically we are using the oxygen of the air. Okay, or also can. Can is cerium, ammonium nitrate. If you check in Wikipedia, you will find exactly, and we get the pyridine, the synthesis of the pyridine. Okay? That means this is the most common method. We generate the 1,5-decarbonyl compound, we add ammonia, and then we cyclize. And we oxidize at the end. Okay? But we have an alternative. Okay, what is the alternative? The alternative is when we have the 1,5-decarbonyl compound instead of ammonia, but we can add is hydroxylamine. Okay? How is working? Well, the same than before. We protonate the ketone, the carbonyl group, and the amine is forming the, in this case, the oxime. Okay? Tautomerization. This never fails. Okay? We protonate again the second, and again we form the other imine, and what we will get is